Hello everyone, welcome back. Most GATE aspirants are scared of network theory. Huge circuits, too many loops, too many currents, too many equations. But here's something surprising. Almost every circuit problem in GATE starts from just two fundamental laws: Kirchhoff's current law and Kirchhoff's voltage law, that is KCL and KVL. If you master these properly today, subjects like nodal analysis, mesh analysis, AC circuits, network theorems, transient analysis becomes much easier. So let's start from absolute basics. First of all, why do we need circuit laws? You already know Ohm's law. But Ohm's law only describes one element at a time. It tells us what happens inside a resistor. We already know this equation, V equal to I into R. But real circuits are much larger. They contain multiple resistors, sources, branches, loops, and interconnected networks. So we need laws that describe the behavior of the entire circuit. That's where Kirchhoff's law come in. KCL is based on conservation of charge, meaning current cannot disappear. KVL is based on conservation of energy, meaning energy gained equal to energy lost. Now let us understand KCL or Kirchhoff's current law. It states that the algebraic sum of currents at a node is zero, or sum of currents entering a node equals sum of currents leaving the node. Sounds technical, but the idea is actually very simple. Before understanding what it means, let's understand what exactly is a node. A node is simply a junction where branches meet, as shown here. If two or more elements connect, it forms a node. If three or more branches connect, it is called a principal node. A branch here represents a single path in a network that contains an electrical component or elements connected in series and connects two nodes. Think of current like water flowing through pipes. Suppose 5 liters of water enters a junction every second, then exactly 5 liters must leave. Water cannot magically disappear. Similarly, electric charge cannot disappear at a node. This idea is called conservation of charge, and that is exactly what KCL is based on. Let's understand this through a simple example. Here we have a node wherein 3 ampere of current is entering through this branch and 2 ampere from the other branch, while I is the current leaving from that particular node. Using KCL, since 3 plus 2 equal to 5, and we already know 3 plus 2 is the actual amount of current leaving that particular node, the total amount of current leaving the node will be 5 amperes. That's it. In gate problems, you can assume any current direction initially. If your answer becomes negative, it simply means the actual direction is opposite to your assumption. Negative current does not mean a wrong solution. Now let us understand KVL or Kirchhoff's voltage law. It states that the algebraic sum of all voltages around any closed loop is zero. Now let's understand the second fundamental law, that is KVL. What it means is, see, we know voltage represents electrical energy per unit charge. As charge moves around a loop, sources provide energy, resistors consume energy. So total energy gained must equal total energy lost. To understand this further, consider a person climbing and descending hills. Suppose you climb 10 meters, then descend 4 meters, then descend 6 meters, your net height change becomes 0. That is exactly how KVL works. Before we try to solve any problems, we need to know the difference between loop and mesh. In GATE, these terms are important. Loop is any closed path in a circuit. As you can see in this particular diagram, there are total 3 loops. But if you consider a mesh is nothing but a loop that does not contain another loop inside it. So automatically for the same diagram, we have 2 mesh inside the circuit. Next, you need to know about sign convention. This is where many students lose marks, but the method is actually easy. While moving around the loop, crossing from negative to positive causes voltage rise. Hence, you should indicate positive voltage across that component. Crossing from positive to negative causes voltage drop. Hence, you need to consider that voltage as negative. Consider the single loop with source and 2 resistors. Source is 10 volt, resistor drops are 4 volt and 6 volt here. So when you apply KVL, 10 minus 4 minus 6 is 0. Hence, we say KVL is satisfied. Now, let us try to solve this particular problem. In this circuit, an independent source of 12 volts is given. We have resistor R1 and R2 with resistance 2 and 4 respectively, and there is a dependent source with a voltage 2Vx across it. One more information we know is the voltage appearing across the resistor R1 is Vx. Now we need to find loop current I and voltage Vx. Take some time and try to solve this problem. Now, let me start solving this particular problem. Okay, the very first thing that I'll do is I'll consider my current direction, or I'll assume my current direction. In this particular case, I'm assuming a clockwise current direction. Okay, what does it mean? The current enters here into the resistor R1 through its left terminal and it leaves the resistor through the right terminal. So I'll consider this to be positive and this to be negative terminal. Okay, resistors don't have any fixed polarities. I'm considering it here in this particular problem based on the direction of current. Next, the same current flows like this, and this is the position where the current enters this particular resistor, and this is the position where it leaves it. Next thing that we need to know is, based on Ohm's law, we know V equal to I into R. Correct? So, what is Vx? Vx is the voltage appearing across the resistor R1. So, it is given by the current flowing through this particular loop and resistor across which that voltage is appearing. Okay, which is nothing but 2 into I. Similarly, what is voltage V2? That is voltage across the resistor R2. Now, this is same as V1. Okay, what is V2 here? V2 is nothing but I into 4 or 4I. Okay, now let us directly apply our KVL. What do we know from KVL? We need to just consider all the voltages in this particular loop and the sum of all voltage will be equal to 0. The very first voltage we see is 12 and the current direction is in this particular way. You can see that current leaves through the positive terminal. So I'll consider positive voltage here. Next we have the minus sign here. So I'll consider minus Vx. And again you can see minus sign here. So it is minus 2Vx. While here it is again minus. But what is V2? V2 is 4I. So I'll write it here. This is actually equal to 0. Now we have 12 minus 3Vx minus 4I equal to 0. But what is Vx? Vx is nothing but, based on this particular equation, 2 into I minus 4I equal to 0. So I'll obtain 12 minus 6I minus 4I equal to 0. So this will be nothing but I equal to 12 by 10, which is 1.2 ampere. So now I have calculated the value of I. We know I equal to 1.2 ampere. Now how to calculate Vx? Vx is nothing but 2 into I, which is nothing but 2 into 1.2 ampere, which is nothing but 2.4 volts. So the voltage appearing here is nothing but 2.4 volts. Okay, that's all about this particular problem.